This is a milling machine. It is used for machining slots in parts, or the edges of parts, or the thickness, or drilling holes. It's a very versatile machine. And I'll show you the basic functions. There's a lot more to milling than this video shows, but I'll show you the basics and the steps to make the pocket in your car here. First step is to take the parallel bars and have one on each side of the vise. Place your part on top of the parallels and then close the vise. If you're going to be machining more than one part, you want to use a part stop. This part stop mounts to the vise and you tighten it around the top of the vise so that when you put a part in the vise, you can slide it against your hard stop. This will locate each part in the same location on the vise, so you don't have to re-zero your mill. You then make sure your part is on top of the parallels, against the stop, and then tighten the vise securely. Now your part is held rigidly in the vise. The next step is we need to find this edge and this edge to make this corner 0, 0 on the mill. We do this by using an edge finder. This part goes into the collet of the mill, and as it spins and hits the part, this separates. So you can then see where the edge is. Because when this separates, this part of the edge finder has contacted the edge of the part. To put the edge finder in the mill, we need to first put the edge finder into a collet. This is a 3/8 diameter edge finder, so we get a 3/8 collet. Slide it in, and then this collet has a keyway. So you slide it into the mill and rotate it until it goes into the mill a little bit. And that way it doesn't spin, it's in the keyway. You then rotate the nut at the very top manually until it threads all the way in and tightens. You then use a 5/16 or 8mm wrench, and this bar here, the bar goes into the hole on the spindle, and then you tighten the thread to tighten the collet into the spindle. It doesn't have to be super tight, just snug. So now we need to locate the edge finder on the edge. So you bring down the spindle. You can see it doesn't go far enough, so we have to adjust the head of the mill. You do this by loosening these two locks here and rotating this, and it'll lower it down. That's a pretty good position, so we lock it. And now this can come down to below the edge of the part. We can do this, we can lock it with this thread here, we lock it in that position. Now we can adjust it with this knob. So we want to bring it down so it's below the edge of the part, and so we can then move the Y direction and touch that edge finder. Each mill is a little different, but on this mill you can turn on the mill here and it'll start spinning, and turn it off with the red button. This knob here is your RPM, revolutions per minute. That's how fast the spindle is spinning. You can turn it on and it gives you a readout of the RPMs. So you want to turn on the mill and have this spinning at 1000 RPM, and then you move the workpiece into the edge finder. And when the edge finder touches the part, this end will move over. And so you want to go real slow until you see this move over and then stop. That is your position where the edge finder touches the part. I'll now demonstrate. So it's okay, you see how it just went to the side? That's the position that it touched the edge. We now zero the digital readout for the Y0. So this diameter on the edge finder is 0.2 inches. So if this edge of the edge finder touched the edge and we zeroed the digital readout, we now need to move the tool, the workpiece, into the edge finder by 0.1, which is half the diameter. So you move it in 0.1 inches and you re-zero. Now your edge, the center of your edge finder is centered on the edge of your part. So that's your 0 in the Y direction. We're now going to do the same for the X direction. So you get your edge finder lined up so that it is below the edge of your surface. And you do the same thing. You turn it on, you move the workpiece into the edge finder until the edge finder moves sideways, and that's your position. I'll now demonstrate. You now zero the X. So I zeroed the digital readout, and now I'm going to move it 0.1 inches into the edge finder, and then you re-zero. And you can double check your zero position by moving the edge finder to your 0, 0 on your digital readout, and then see that it's on the very corner of your part. You now have the mill zeroed on the corner of your part. Okay, now that we found the 0, 0 on the part, we need to take out the edge finder and put in a cutting bit. So you need to unlock the Z-axis, so you can lift it up, and now you can use your wrench to loosen. Keep in mind when you loosen this thread, the edge finder may drop out, so you want to hold it and then take it out gently. For this part, we're going to use a 1/2 inch end mill. So this end mill won't fit in the 3/8 collet. So we have to take that collet out by unthreading all the way and getting a 1/2 inch collet. And place the collet, rotate into the key groove, thread it in a little bit so it stays. Then take your 1/2 inch end mill and slide it in there. You have to hold it while you tighten the collet. Once you have it snug, then it'll stay, and then you tighten it with the bar. Keep in mind, these end mills are very sharp, so be careful of your fingers. So per the drawing, we need to move from this edge 1.25 inches, and from this back edge, a 1/2 inch in from the edge. So our digital readout is set to that corner, so we move the bit to the first position we want to cut. You might want to double check the position by gently holding the bit down against the workpiece and seeing that it's in the right position. You then bring the end mill close to the workpiece and lock it in place. Now you can use the wheel on the front to adjust it up and down. You can use this digital readout for the Z-axis, which is the vertical axis. Okay, we are now going to cut a slot in our part. To do this, you turn on the mill, bring it up to the right RPMs, and then lower the end mill into the part. It's called a plunge. To know what RPM to use, you can look at this chart. We're using a 1/2 inch end mill, so it's about 2,000 RPM for aluminum. For steel, it would be 300 RPM. This is a rule of thumb. You can adjust the RPM if it doesn't look right.